Today I'll be, as I had told you, I'll be taking you through the chapter Light. I'll talk to you about art integration in science today, along with Light. And actually the chapter Light, we can demonstrate most of the ideas through activities using lenses and mirrors from the lab. So I think that is the best way to teach, and for children also, they find it easiest to learn when we use mirrors and lenses that are available in the physics lab. So I think that is one of the ways in which you go about. And especially in class 7, when we learn about mirrors and lenses, the terms like principal focus and center of curvature are not dealt with in the chapter, as you have noticed, I think. If you are following the NCERT textbook, then you would notice that the particular terms are not there. I am not aware of what the other publications books, whether, ma'am, those of you who are using other books, could you please tell me?
We have Oxford, ma'am.
Oxford. Does it have the terms principal focus, center of curvature?
Just concave, convex, how it visible, every output.
Yes. So that is usually the case, because as NCERT frames or CBSE frames the syllabus, rest of the publications usually follow that pattern. Only the way they explain the topic will be different. Otherwise, content-wise, almost it is similar.
But activity alone lays in the
Yes, you are right, ma'am. So that is something that we have all encountered. I mean, if when we go to higher classes 9 and 10, then we teach them to draw ray diagrams and so on. But in class 7, we don't have all that. So sometimes that becomes a bit of a challenge, because children don't seem to understand, because we have not been able to teach them about the central axis and how we put objects in particular locations, and then chalk out the or draw out the ray diagrams. So here we will have to follow the method of actually doing the activity and showing it to them. So it's 11:34 and I have some more participants who have come in. So I will start sharing my screen, and once the number of participants increase, I would share the question paper details about the assessment, because many of them will not be there, are not there now. So at least we usually have around yes, ma'am. Some of them have sent yes, they have sent messages saying that they have exam duty. So when any of their colleagues are there, then they can pass on the information to them. Yeah. So shall we start with the chapter? Because I think today I got a message from Purnima ma'am, and also, if I'm not mistaken, Shanti ma'am. They have duties. So I will talk to you all about the question paper probably around 12:30 or so. Okay. So today, in fact, because light is a chapter which we have in class 6, 7 and 8, but in different ways. We will look at them step by step. I have not filled in the class 8 portions in my PowerPoint presentation. Because it is difficult to cover 3 levels in the time span that we have. So if time permits, we can have a short discussion with all of you, and we can probably work on it. I would also like to share with you a question paper that we had for the common term 2 exam, and we can analyze it and go through the paper to see how we can go about incorporating Bloom's taxonomy and higher order thinking skills into our papers. So I'll start right away, and I'll be sharing my screen shortly. Just give me a moment, teachers. Are you able to see my screen?
Yes, ma'am.
Yes, ma'am.
Okay, thank you for your response. So today being the last day of our online program, we will take on from here to the topic light. So here I have noted the contents of basically only the class 6 lesson, but while describing, I have gone on to touch upon class 7 portions also. But as I said, class 8 portions are not included in the PowerPoint presentation. If time permits, we can have a discussion on it. So we'll be basically looking at light, shadows, and reflections. The characteristics of objects in terms of whether they allow light to pass through them or not. So transparent, opaque, and translucent. What are shadows? Pinhole camera. We will pursue activities which help us to understand that light travels in a straight line. And we will learn about mirrors and reflection. We will also have a short section on spherical mirrors and lenses. So art integration, today we will, before going into the topic, let us just look at what is AIL, or art integrated learning. So art integrated learning has been taken up by the CBSE as a teaching learning model, which will help children to understand the concepts in a particular subject of the curriculum when they link it to arts. Because research has provided evidence that children learn better when we integrate art with it. And art integration is actually slightly different from art as a study. Art, many of you may be thinking that art by itself is a subject. So why do we integrate it in other subjects? The whole idea, we will see what are the benefits of integrating art. So it's a teaching learning model which is based on learning through the arts and with the arts. It is a process where art becomes the medium of teaching and learning and a key to understanding major concepts of a particular subject. So it is basically an approach to teaching where children are allowed to construct and demonstrate their understanding through an art form. And here, when we say an art form, the art form could be in visual arts or performing arts in any particular way. So yesterday, for example, when we were doing body movements, one of the art integrated activity for body movement chapter would be probably a series of aerobic activities or a dance program with simple body movements, where you can also have a child explaining certain things, and having some other children perform. So you can integrate art with learning. Students engage in a creative process which connects an art form and another subject area and meets the objectives in both. So it is basically, we are now advised to integrate arts not only with science, we integrate art even with maths, social science, English, or any other Indian language that our children learn. So it has definitely, helped the learning process and the teaching process too. So here, children are allowed to creatively pursue their ideas, where they learn to create, they learn to explore certain concepts, they experiment on it, they develop some crafts, they imagine some activities, how to present a particular concept in a creative manner, and then they share their ideas among themselves and with the teacher. And this allows them to reflect as an assess on their own understanding of a particular concept. So the creative process, as you can see, involves all these parameters, and it helps them to create, to explore, experiment, and develop craft, imagine, examine, perceive, share, reflect, assess, and revise. So that is the importance of the creative process. So when art is integrated with education, children apply their art-based inquiry, their art-based investigation, think critically, and they have a deeper understanding of concepts. So when we tell children that a shadow is basically when light cannot pass through an opaque object, you have a shadow. So here when they do an activity involving shadows, as we will be seeing later, when they do an activity, they actually understand first what is opaque, what is transparent, what is translucent. When do we have shadows? Do we have a shadow if there is a transparent object in front of a source of light? Or do we not have one? Do we have a shadow with a translucent object? Or will we get a better shadow with an opaque object? So automatically that gets incorporated into the activity that the child is doing. We will be seeing how we can use shadows as an activity, which can be an art integrated activity, and it's a very enjoyable activity for children, especially of the age group when where they are in class 6. So it helps them to have a deeper understanding of the concept. They also get to understand that a shadow gives us some information about the object, but not a total information. So which is why probably if you have a cylinder, then at a particular angle, your shadow will be circular. And at a particular angle, the shadow shape will change. So basically, you are not going to get a very clear idea of the shape of your object. Depending on how your shadow is, your perception may change. And at the same time, they will also understand that for some objects, it is easy to understand that or infer how the object may be. So that is an understanding they will explore how shadows help us to learn. Then secondly, art integrated learning is a strong contender for experiential learning. That is learning with experience, what the child experiences as the child goes through the process, as it enables the student to derive meaning and understanding directly from the learning experience. So here also, for example, we have, if I take into account the three kinds of, medium, that is an opaque, a translucent, and a transparent medium. We can ask the children to draw any scenery or any art that they are interested in. So let them draw anything, and then we can have that as the basic. For example, if I'm using this as the picture, this can be my major picture. And then I can stick it on a cardboard and have flaps of paper coming out. So you can stick paper on this side, on the top, and on the side. And then one of them could be an opaque sheet, one could be a transparent sheet, and one could be a translucent sheet. And then we can ask the children to put the opaque paper over the picture and say, are you able to see the picture now? So they will obviously say no. And then they understand that an opaque surface will not allow light to pass through, and therefore we can't see the picture. So the second thing that they learn is, you can see the picture only if light from the picture reaches your eyes. So that is how they experience what we talk to them. Because when we say, how do you see things? It is quite difficult for a child in class 6 to understand that when light falls on things around us, it gets reflected, reaches our eyes, and that is how we see. So here we will be able to make them understand it even better. Thirdly, art integration aids in the development of certain life skills. And that is what we are aiming for. We would like our children not only to acquire academic skills, we would also wish for them to acquire life skills, which are very important. And the focus of learning is gradually to move from the rote learning method to the 21st century learning skills. Now, what are these 21st century learning skills? These are learning skills which also utilize, besides academic skills, certain life skills like communication, reflection, and inquiry skills, higher confidence levels and self-esteem, appreciation for aesthetics and creativity. Now, all of us are aware of the fact that science plays such a huge role in our lives. It cannot be undermined. But are the arts not essential to our life? Because when we feel, for example, we can give children the idea, see children, however much we may study, there are times when we need to relax. And when we need to relax, we probably listen to music. So when we listen to music, the musician who has made that piece of music is actually allowing you to relax, so that your productivity increases once you are done with your relaxation. So music is also a very important part of human civilization, of the life of every human being. And therefore, the world needs not only scientists and engineers and doctors, we also need artists, we need our dancers, we need our musicians, we need people who are very good at performing arts, people who can make us laugh, people who can just improve our lives by being there. So that is life skill, and we really need to see that our children develop those life skills, because being successful in life is not just about being intelligent. We all know that IQ doesn't only determine how successful an individual will be in their lives. A lot of it is decided by our emotional quotient or our attitude towards life. And it has been found through research, that one of the very important factors which determine how successful a person is going to be is not in his or her mental abilities or cognitive functions. There are some other qualities which determine whether or not a person is going to be successful in their lives. And one of the important qualities is what is termed as grit, Grit, grit. Now, what is this thing called grit? It is something that we definitely don't teach in our classroom, how to acquire it. Now, grit is the ability to stay put even when the situation is difficult. The CBSE has included art education, integrated art education has become very important. So it also builds on confidence of children and their self-esteem, and they appreciate aesthetics and creativity. This kind of integration also broadens the mind of the student and enables him or her to see multidisciplinary links between subjects, topics, and even real life. So actually, once previously the arts and the sciences were very far away from one another, and we did not see much intermingling of them. But now it is understood that the multidisciplinary approach, when we explore that, we are able to teach better. And there is a link between all subjects. So when we teach science, we know very well that we need to touch upon some core areas in maths. So that is something we are all aware of. So especially when we teach things in physics or chemistry, we do take up some mathematical concepts, because we use a lot of maths to solve the numericals in physics and also in chemistry. But do we use mathematics in bio? Yes, we do. Do you agree, teachers?
Yes, ma'am.
Do we use maths in bio?
Yes, ma'am. In genetics and all, the Mendel's theories.
Yes, absolutely, ma'am. This is exactly what I was looking for. Gregor Johann Mendel could come up with his theories of genetics because of approaching the whole issue with a mathematical frame of mind. That is when he started to take a count of the number of genotype and phenotype, and that is how we have ratios. Okay, the phenotypic ratio and the genotypic ratio, and that brought about such a change in the in fact, that is how Mendel is today known as the father of genetics. So we use maths even in biology, which is not probably very obvious when we start off. Children may feel, even when we examine the arrangement of the petals of a flower, can you see a beautiful geometry in that? There is a beautiful geometry in that.
Yes, ma'am.
Yes, ma'am.
Yes, because
Yes.
when 5 petals are arranged, and those of for us here who are botany students, you know, our floral diagrams that we draw, they are such beautifully balanced. There is beautiful symmetry in nature. So symmetry is another concept that we have in maths. But art,
Patterns also.
yes,
Pattern also.
yes, patterns. And we have the arts draw a lot from, because it has been, again, when scientists try to find out that what is it that makes something beautiful to the human eye, then they found out that a lot of it is based on symmetry. The human eye tends to see symmetry as beauty. So if two halves of an image are very similar, then we find it more beautiful. So Albert Einstein famously said, "I'm enough of an artist to draw freely upon my imagination." Imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. So this is something that we need to remember, because imagination gives wings to our thoughts. It is by imagining that we can do something which is not existing. Imagination is what allows us to create. And very often we hear that children tell us, "Miss, I can draw, but only if I have a reference picture. I cannot draw if you ask me to draw from my mind." Have you heard that, teachers? So this is the website which I have. It is there in the PDF, and I'll be, which is there in the PPT, and I'll be sharing this PowerPoint presentation with you. If you wish to go into and research on art integration, which is available in the CBSE website, this is the website here, which I have shared. So you can read, you can read and get your ideas from there and learn more about it, in case you already haven't. Some of you would have already done that, I know. This is just the kind of art experiences that we can have. It could be visual, where we can ask children to use their drawing and painting skills, or clay modeling. Yesterday, we had an activity where we checked out clay modeling for understanding why a skeleton is important for for movement. Then pottery. Here, if it is not clay, which is molding clay, they can also have paper mache, where paper is kind of have you do you have an idea about paper mache, teachers? Where paper is soaked in water, and then you can apply glue to it and make it stronger, and then craft out items from it. So that can also be done. Paper crafts, mask and puppet making, and various kinds of crafts. Performing arts like music, dance, theater, and puppetry. Here, all the role plays that we do, these are also performing arts. They are art experiences. They lead to a better understanding and construction of knowledge about different topics and concepts. So here I just have an example. Now this is a very, very famous site in Chicago. We have tourists going up to it. And this is an art design which is called the Cloud Gate, or also the Bean. You can see it installed here. And it was designed by an internationally acclaimed artist called Anish Kapoor. He is an Indian born British sculptor, and he has used a reflecting surface to make this huge piece of art. So our knowledge of the sciences also goes hand in hand with art. So Cloudgate was his first public outdoor work in the United States, and is considered one of his most famous exhibits. So this is an example of how reflecting surfaces are used as a work of art. And then we can have various ideas like, nowadays every child has become, very used to a mobile phone. And one of the key features of a mobile phone is its camera. And children are very gadgets. May I request the participant who is unmuted presently to kindly mute. Thank you. Okay, so we can give them a project, or we can give them an activity where they are going to take photographs of reflections. It's called reflection photography. And if you, if you do a search on the internet, you can have beautiful ideas that can be incorporated in this project. So here, light is used to take various beautiful pictures. So I just have two examples here. This is from a road, actually, where there was a waterlogging. And you can see that is how inverted images, because these are all reflections. And this lake surface is a natural reflecting surface and has been used to take a beautiful photograph of the clear water and the sky and the, the vegetation which is there. So this is another example of art integrated project that can be assigned to children, where we can ask them to take around 5 pictures or so. And we can always ask them whether it is comfortable for them to do it before we assign such a task, or we can give them options. If you wish, you can do this, or you can do something else. So these are a few examples of art integrated projects. I have also a few other projects which I have pushed towards the later slides. The next one is an activity. So this activity is something which is not there in the textbook directly, but it's a very easy one. In the textbook, we have one with a pipe. I hope you have, I'm sure you have seen that, to see that whether light travels in a straight line or not. I have not included the activity of a pinhole camera in my PowerPoint, because that is something which is there in the content, and we will definitely ask children to make one. So since it is easily available to all of you, I have not included it in my PowerPoint. So that is, of course, one activity that we ask them to, to kind of get involved in, to make a pinhole camera. The other one, where they can check that whether light travels in a straight line or not, is a very simple activity, where instead of cardboards where you make a hole and do all this kind of things, all we need are 3 CDs, and these are pegs that we use on the clothesline, the clips which we use, and we make a stand with that, and we allow these 3 CDs to come in a single line, light a candle at the other end, and then observe from the other end. And we will be able to see the candle only when the holes are aligned in a single straight line. So we can ask the children to move CD number 1, 2, and 3 and see whether they are able to see the candle or not. So this gives a very easy activity which children can easily do at home, because most of us have old CDs lying around, and everybody has these colorful plastic clips to hang our clothes once they are washed. So it can easily become an activity to understand that light travels in a straight line. So I hope we will be able to use this activity in our classrooms. We can ask children to bring the material and we can do it in the class. The candle, I think it is safer to ask children not to bring candles and matchbox. You can be the only person providing the candle and the matchbox, because we know children can be mischievous at times and they will not be careful enough, a few of them. So let us not ask them to bring candles and matchboxes. The candle and matchbox we as teachers will be giving, and we finish the activity in the classroom and remember to take the candle and the matchbox back with us when we leave the classroom. So we always need to keep safety in mind. And this is another activity which is very similar to the previous one, but here there is a slight difference. Now I will allow you to look at this arrangement for a moment, and I think it is quite self-explanatory. Here we understand the role of mirrors as reflecting surfaces. So you can see the source of light here is the torch of a mobile phone, and instead of these, again we can have CDs here. This particular activity has bits of paper, and then there is a mirror here and another surface with a hole, and this box acts as a screen. So what we have to do is, we instead of a box, we can have a board or something like this here, and move the mirror till we obtain an image. We can see the reflected light here. And this shows us that the reflected ray which was going, the ray of light from the source which was going straight has bounced off, or it has been, reflected from the surface of the mirror and is now going along a different path. So here they can understand reflection very easily. And instead of a mobile phone, if we use a infrared pointer, a laser pointer, then this becomes easily visible as a straight line. I'll be stopping my screen share, and let us have a look at the activities that you have already done. Teachers, would you please give forth your ideas that you may have carried out, some activities to show that light travels in a straight line and so on? Please feel free to share your thoughts and activities, whatever you have done in the classroom. Do you feel that these activities can be easily done in the class?
Yes, ma'am, it is easy only.
It is easy, right, ma'am? Materials are not difficult to obtain, and they are all. It's an activity which is not very complex, yet it easily helps children to understand the concept. Do you agree with that? Will you be able to kind of recreate them in your classrooms? Or if you have done some other version, that is what I have been asking. If you have any other versions of these experiments, does anyone have any other idea that they had executed in their school? Okay. Okay. So I think I will just continue. So this is another activity. And then let us see what follows after this. Okay. Now this is an art integrated activity that I have, incorporated in my slides, a shadow puppet story. So this is a short story where a child uses puppets and shadow to convey a small story. So we can ask children to do something along these lines, which will be an art integrated activity. So they will not only understand the concept of shadow, light, they will also build some skills of speaking. They'll use speaking skills. We can see this child here has narrated a story really beautifully, and that is something that children need to develop as a skill, the skill of public speaking. And also they will be able to recreate a story. They become storytellers, which I think is a very important thing in life, to be able to tell a story. And also everybody else is going to enjoy this. So let us see how this works.
Hi friends, my name is Tanya Redis. Today I am going to tell you a story using shadow puppets and my shadow theater. The title of the story is Who is Happy? This story teaches us not to let go of our happiness by comparing ourselves by someone else. Be happy with what we are and what we have. Now let us start our shadow play. Once upon a time, there lived a crow. It was very sad. The crow was very unhappy because it thought it was not beautiful. One day, the crow met a beautiful swan. The crow thought, wow, it is very beautiful. It has white feathers. The crow told to the swan, "Wow, you are very beautiful and I am black. Is it? But I think the parrot is the most beautiful bird. It has two beautiful colors." Then a crow met the parrot and told, "Wow, you are so beautiful. No, I think peacock is more beautiful than me. It is multicolored." Then the crow went to the peacock and told, "Wow, you are the most beautiful bird in the world." Then the peacock said, "My dear crow, you are the luckiest bird in the planet, as you are never caged. Because of my beauty, I am trapped many times in a cage, and you are free." On hearing this, the crow thought how foolish he had been and thanked God for making him the way he was. The moral of the story is, never compare yourself to others. As I said, be happy with what we are and what we have. Thank you.
So teachers,
Hi friends.
so
Nice
teachers,
video.
My name is
yeah,
Nice video.
yes, ma'am. We can ask our children to do a similar one. There, if you search the internet, you will have beautiful ideas of how to make that screen. We can have a cardboard and cut out the center and put a translucent paper on that, and even make stands using cardboard. And we can cut out pictures of different animals. In fact, there are other videos, but they are longer, which is why I did not choose them, where you cut out parts and attach them with some pins so that different parts move if you move two hands and your puppet moves. So you attach a long stick to it and it moves. And teachers, we can ask our children to work in groups again, and our Panchatantra stories are beautiful to be shown on a shadow puppet. So we can ask children to have an art integrated activity using shadow puppets and our Panchatantra stories. So we teach them science, we teach them the art of speaking, which is a part of English, so to speak, that is language skills, and we also build on their values. So one activity takes care of so much of learning. So I think this was a beautiful, and I really was impressed by the way this small child has shown us. Don't you think so, teachers?
Yes.
So if we give our children an opportunity, I'm sure they will be also able to do something similar. And many of them will have talents which we probably are not aware of as science teachers. But when we, kind of investigate and make them do a lot of other activities, then a lot of other qualities of our children come to our notice, and children feel happy to, to be able to participate in the class, to help, they can display their skills, and overall it's an enjoyable experience for everyone. So this is one of the activities that can be done easily using a simple material. So I'll be sharing my screen again. Just give me a moment, please. And then teachers, when we are talking of shadows, we can tell our children about a concept which is the zero shadow day. We recently had a zero shadow day in the previous month. Are you aware of the zero shadow day, teachers?
Yes, ma'am. There is no shadow formation.
Yes.
The sun will be come in the straight line.
Yes.
Am I
So
right?
you are right, ma'am. So actually, if I stop sharing, yeah, ma'am, and a zero shadow day, because we are in the tropical zone, for us it is very easy because we experience it here. So we can definitely take use of this zero shadow day to make children understand the journey of the sun, the inclination of the Earth's axis, and shadow formation. Again, we are integrating 3 different topics. We are taking some topics from social science, some topics from science, and we are executing an activity. So this is again art integrated learning, which also is interdisciplinary in approach. So that is another activity that we can definitely share with our children. So I'm again sharing my screen to help you to have a view of this particular one. Are you able to see my screen?
Yes, ma'am.
Yes. Okay. So this is the zero shadow day.
Let us
Sorry, I'm not being able to play it on the full screen.
place this hollow PVC pipe here. We will use flashlight of mobile phone to create a shadow. Shadow appears on either side of the line as I move the flashlight. If I move the flashlight exactly above the pipe, I cannot see the shadow. I can put this pipe on a transparent sheet and get the same result. This time, I see a circle below when flashlight is exactly above the pipe. Something like this happens in real life as well. We see shadows all the time, but they appear sideways at noon except for 2 days in a year. These 2 days are called zero shadow day, a day when shadow disappears for some time at noon. Why it happens? We will see later. Let us do the setup first. We'll fix these cycle spokes to the wooden base and place acrylic sheet on it. We'll take some hollow shapes and place it on the top. Let us watch shadows as sun moves above us. On the zero shadow day, based on the location when the sun is exactly at the top, you will see a full circle as shadow of a pipe. You can do your setup with these everyday things as well. Outside, it is always advisable to wear chappals or shoes and put cap on your head. You can take help of other shadows as well while you are watching this. Now let us explore why it happens only twice a year. As you know, Earth is rotating around Sun and around itself as well. Its axis is tilted by 23.5 degrees. This is the reason for seasons and Sun shifting positions as it rises and sets every day. Sun rises at different time and location as well throughout the year. In this simulation, you can see how shadow changes at noon throughout the year. You can enter your location and try it out yourself. Hope that helps. Thank you.
So teachers, this was yet another application of shadows and awareness about the Zero Shadow Day, and very simple activities which children can participate in with regular things that are available at home, and it generates interest and helps them to learn better. So after this, we move on to shadows, to image formation by a plane mirror. This is yet another video, but since it's 12:21, I think you will be able to understand that we have a plane mirror and a candle and a line here, which is about, I think it was around 9 point something. So if we move the candle along this line, when we go shorter distance from the mirror, then the image also moves towards the mirror. This is what can be shown to children so that they understand the properties of images formed by plane mirrors. And the image has the same size as the object. The attitude, which is how is the image? It is upright but laterally inverted. And images at the same distance from mirror, and these are all virtual images. So virtual images, of course, we have to make them understand that those images which are not obtained on a screen are called virtual images. And then comes the concept of concave surfaces and convex surfaces. I'm stopping my screen share for a moment. And here we have moved on from the class 6 content to the class 7 content, where we talk to them about plane mirrors, the characteristics of the features of the plane mirror, and the textbook has an activity with checkerboards. So we can ask children to bring a chessboard and keep the mirrors that we have in our laboratories, the plane mirrors, and then kind of see the number of boxes that the image moves when we change the location of the object. We will usually use a candle, or here we can use even an eraser or something as an object. So that can give them a good idea about mirror images. And we talk to them about lateral inversion of the image, where if we ask them to comb their hair in front of a mirror at home and observe what it feels like, with their mirror image. So that can be a very simple activity to help them to understand mirror images. We can also ask them to write alphabets, and we can involve so many of the children and check out which of the alphabets get laterally inverted, and they can even learn to predict them. So this is a simple activity which can help them understand lateral inversion by mirrors, that is plane mirrors. And after this, we have activities on concave mirrors, convex mirrors, and lenses. Now, basically, teachers, what I feel is that unless we do the activity in the classroom using actual mirrors and a screen and a candle as the source of light, it will be very difficult for children of class 7 to actually understand what is going on when we move the object here and there. So how have you gone about teaching it in your classroom? I think some of you would have already used the material to, to give them the ideas, because that is what we usually do in our school. We take the mirrors from the physics lab and bring them to our classroom, and we use the teacher's table, a candle, and a screen, where sometimes I use a cardboard box which has been covered with white paper, and we move it around. And sometimes even the door of the classroom becomes the screen. So we can use it in various ways and explain to them image formation by mirrors and lenses. But if we just talk to them about it, it is not at all, they don't understand it, because we generally don't use curved mirrors in our lives, in day-to-day life. So they don't have any idea about it. So here again, I have an activity which, if you have those laser lights, then we can do it. We need 3 of them. So the one which I have as an activity in the video has a light which, which has a single light from which 3 beams come out. So I'll be sharing that with you now. Now, before we go on to the activity, we have to tell children, I have seen most children make a lot of errors with what is concave and what is convex. So the best way to help them to learn this is to have them bring a spoon from their homes. Usually most children have a spoon with them for their lunch pack. So we can ask them to take out the spoon and then have the concave surface towards their face and tell them that this is the concave one and the opposite one, which is the back of the spoon, is the convex one. So we have to repeat this quite a few times for children to understand what is concave and what is convex. Another method which I have found, helps children to remember which is concave and which is convex is by drawing their attention to the word cave. A cave. So we tell them about caves. They have already read about caves in younger classes, and they know that some animals like to live in the caves because the cave has a hole. It has got a depression into which you can go. So a concave mirror is the one which has a depression. There is a cave-like thing in a concave mirror. So that is when they can relate to a concave mirror and not mix up a concave and a convex mirror. So have you had that issue in your class where children get very confused with which is concave and which is convex?
Yes, ma'am.
So a concave mirror, teachers, we can help them to understand by saying there is a cave in the concave mirror. So the opposite one is convex. So this is an activity which here, instead of a mirror, they have used a highly polished surface which is curved like a C. And again, this helps them to see the concave and convex mirrors.
The learning intention for this lesson is that you will understand how light is reflected off concave and convex and concave, and draw scientific diagrams to demonstrate the reflection of light off a convex and a concave mirror. Here I've got a round mirror. Now both sides of this have been mirrored, and if the light is going to hit the inside of here, we say this is the concave surface. So it's a concave surface. I remember this as though, like, if you're walking into the cave, it's concave. The other way, if the light was to hit on the outside, this we call convex. So concave, walking into the cave, the light is going to go into the cave. Convex, it's going to hit the outside. Okay, now the way the light behaves with a concave mirror is that it will actually focus into a specific point. So the light, you can see it there, it's traveling in straight lines. I've used the triple beam here just so we can see how it's behaving. So we've got 3 beams that are going to hit the mirror, and they're going to get reflected towards one another to create what we call a focal point or a focus. Okay, so you can see that point here.
So teachers, I think you are able to understand what this particular video will be. I'm not continuing with the whole one because it's already 12:30. I have a bit more to go with, especially the activity with the spherical mirrors. Meanwhile, I'll just stop sharing my screen because I would like to take in the attendance for the day. So would you just give me a minute while I take in the attendance? Thank you. So teachers, what do you feel? Did that concave mirror activity, do you think it was very useful?
Yes, ma'am. It's nice,
Because
nice explanatory.
it is very easy to see the converging rays here. But if we have to do it in the class, because I have not actually done it, we will need to get a highly polished surface which is going to be able to reflect the three beams. So that is one thing we will have to work on before we show our children. But since it was a good idea, I thought of sharing with you. And finally, we have our mirrors. And then, of course, followed by lenses. Now, I don't think we will have the time to go through both mirrors and lenses. So again, the video that I found on the internet is exactly the same as what I do in the class, or most of us do in the classrooms. So I'm just going to play the video because, as I said, right now I'm working from home and it is not possible for us to get things from the lab at the moment. That is why I am not working it out for you. And also it is easier to see it on a video because here I have to align my camera with my surface and so on. So this is the next video will tell us how to go about teaching children about mirrors, concave mirrors, convex mirrors, and their position. So if you see the science textbook with light, we have after plane mirrors, that is what the textbook talks about, how we get our reflections from curved surfaces. So shall we proceed with that?
Yeah, yes, ma'am.
Okay, thank you for your response. I'll be again sharing my screen and we will go on to the next activity. Which is a concave mirror. So most of our labs, in fact, all of our laboratories will have concave mirrors. And then we will usually have the similar kind of a stand also. So let me see whether I can put it in slide. Yes. Now this is a slightly long video because there are so many positions. Are you able to see?
Yes, ma'am. Audio and video clear.
Yes.
Hello scientific audience, how are you all? So as promised, I am back with a very good demonstration which is the image formation by the concave mirror. Now this demonstration is for grade 7 till grade 12. All students can understand this well. For this experiment, I have taken a concave mirror of 20 cm focal length. As you can see, this is our mirror. It is mounted on a wooden stand. You can also choose concave mirror of any other focal length. We require a scale to measure all the distances. We require a candle, which is going to be our object. This candle is mounted on a plastic cap. And the screen. The screen is basically the white paper, which I have fixed it on a small plywood piece, and I had asked my carpenter to join two pieces of plywood on which I have fixed the A4 size paper, because we are going to obtain the real images, and real images are obtained on the screen. So now let's move ahead with our experimental part. So here what I have done is,
well, teachers, I just paused the video because I just want to include this particular insight into the video, is that in class 7, as I had told you right at the beginning, we don't have terms like focus and center of curvature for our children. So let us we will keep these points, the focus and the center of curvature, on the table with a line, but we will not there is no requirement to tell the children about these points. We can just have them as points and not go into further discussion with the children about the significance of these points, what they are. So while teaching, we always tell them that a spherical mirror is a part of a sphere. That we need to say, but the focus and center of curvature, or the center of curvature is double the distance, all that is not required. We just have the points and we'll work on it. This is something that I just wanted to add.
I have joined 3 A4 size paper, then I had drawn a line, and then I have marked the distances 20 centimeters, 40, 60 and 80 centimeters. All those points are marked, and all these points are the distances which are measured from the mirror. The first case, the object is placed between the pole of the mirror and the focus. In this situation, we know that the image is going to be formed behind the mirror. It will be virtual, erect, and it will not be obtained on the screen. So even if I move the screen backward and forward, the image is not obtained on the screen.
So the textbook talks of the candle when it is kept very close to the spherical mirror, then what kind of an image do we see? So we know that it is between pole and focus. Children don't know that, but we can just tell them the position is very close to the spherical mirror. And there is a table on one of the pages of the lesson where there are these headings between 15 centimeter to this much, beyond this much. So we will ask the children to observe what we are doing, note the position and fill the table as we are going about. So my table is also there after this particular video. So I'll talk about it after that. I'll just play it again for you.
Now here guys, you can see that on taking a closer look, you can see the image is behind the mirror and the image is actually bigger than the object. You can see the size of the candle being enlarged over there.
When the object is very close to the mirror. This is a concave mirror.
Now since the image will be formed at infinity, so even if I try to move the screen forward and backwards, I will not be obtaining the image on the screen, because the screen has to be very, very far away from the pole of the mirror to obtain the image. Be larger than the
Now, this is
object.
the next position. We have to move the screen to obtain the image. We'll have to tell the children to notice that the flame is upside down. So we move till we get a clear image.
When you move the screen and when you finally obtain the image on the screen, you should be careful that the image must be sharper. So the sharpest point would be considered as your image distance. You can move the screen forward and backward to check the sharpness. Wherever you get the sharpest image, that location would be your final image location.
Teachers, I'll be pausing the video because I think by now you have understood how we will be proceeding with all the positions. And I have stopped the video because we will be running short of time if I play the whole video. So I think this will help us to understand that in order to make this entire section, which is there in the textbook, understood by our children, we cannot give them a description of it. We cannot draw diagrams on the board either, because it will not go down very well with children when they are not able to understand, because what they see are plain mirrors, and what they see are images equal to the size of the object, and they always see virtual images, the ones which cannot be obtained on a screen. So for them to understand that the nature of the image is going to change with the position of the object is something very, very abstract, which unless we show them, they will not be able to grasp it at all. So similarly, there are this same series of experiments have to be repeated. They would rather be done again with our lenses also for children to understand it well. So I don't think there is, any other way by which we can make our children, that is of class 7, understand how image formation occurs, other than by actually making them experience this whole, you know, image formation. And once they see the beauty of the change of position and the kind of image that we get, we can ask them to note down the characteristics of the image as we move the object away from the mirror gradually, and that will help them to understand. I'm stopping my screen share. That will help them to understand what exactly the literature in the book is all about. So teachers, this is something that is a very hands-on learning for our children, and I feel that even with a convex lens we will need to do it, and this will take some time, because it's a very new concept that children are trying to grasp, especially in class 7. So we will have to patiently explain to them. There will be many excited inquiries. There are some children who will come up with all kinds of questions. If we have our patience and deal with it, then I think this learning will be something that children will enjoy. That with mirrors we can have so many, there are so many applications of the mirrors as well, because when the object is very close to a concave mirror, then we get an enlarged image, and we apply that. We can ask some children if anyone has been to a dentist, and if they have observed that their dental surgeon or dentist has been using mirrors to check their teeth, and we can then tell them how, since the mirror is so close to our tooth, it is always desirable to use a concave mirror, and it helps the doctor to get an enlarged view of our tooth, which helps them to treat our dental caries or whatever issues that we may having with our teeth, and help them to treat and work on our teeth. So these are applications immediately we can correlate as and when the image formation happens. So similarly with a convex mirror. And then we move on to lenses. So it's 12:44 and I just have 15 minutes with me. So shall I just wind up with the light? What do you feel, teachers? There was one very simple activity of making a rainbow which children may enjoy. It is there in my PowerPoint presentation, where you have a glass of water, and if you keep it against the window, then you will be able to see, depending on the position of the sun. And if the sun position is not favorable, we can use a torchlight to get a rainbow on the floor. So that is another activity that children would love to work on. So these are a few things in light which we can work with. We can have integrated art ideas also with it. Some children would like to make decorative pieces with mirrors. Because, in embroidery in India, in Gujarat, there is beautiful embroidery which is done with mirrors. So these are all art integrated activities and ideas that we can give our children. So if there is anybody who can do it, maybe they can have simple flower or something like that, which is a glass where they have, kind of stitched up. Because mirror inlay work is something which is a very renowned art of India. So which is pursued in Rajasthan. So we can talk to them about it, make them aware of all the arts and craft. There is a special kind of metal mirror which is made in a particular place in Kerala, and those mirrors are famous because they are metallic mirrors. So we can talk to them about the importance of mirrors and lenses in optical instruments. We can tell them, even recently, I think yesterday I was reading about a telescope which has taken pictures of the black hole. Have you read about it, teachers? The very, something very, scientists are very excited about the pictures of the black hole. So that is possible only because of lenses and mirrors. We have to bring to notice of our children the fact that many advances in biology, for example, without a microscope, we would have never known about the structure of cells. And a microscope works on the basis of reflection and refraction. Telescopes work in a similar way. A periscope works along a similar way. So we can ask them to recreate or construct a periscope. We can ask them to construct a kaleidoscope, which children love doing. And then we can ask them to observe inside the kaleidoscope, and we can talk to them about fractals, okay, which is a concept of maths, of course, okay, where you see repeated units of something. So those are so many, applications of so many applications of physics or science in other disciplines. Let me very quickly, I will share a question paper with you very quickly, because going through an 80-mark question paper takes a lot of time, but I'll rather run through it so that you can have a fair idea of how we go about, how we may go about framing questions. Okay, so this is a question paper that, are you able to see my screen, teachers?
Yes, ma'am. Visible.
So this is a question paper that we had for the last exam, which was the term 2 exam. And we have, of course, designed it as per CBSE guidelines. So we have section A, which is totally MCQ based. And here, as you can see, we have 4 options. I think that you are very aware of. But one thing I would like to draw your notice to is the fact that when we design a question paper, if you see, okay, so this is just an overall look at it. When we design a question paper, we use a lot of diagrams in our papers, because science becomes more interactive then. And also, dear teachers, please try to avoid choices as all of the above or none of the above. All of the above and none of the above as choices in MCQs should be avoided, because it kind of, I think it just reflects the fact that the question paper maker is, has run out of options. So we are not recommended to use it. So if you see this question paper, none of the options are given as all of the above and, none of the above and all of the above. So some questions I would like to draw your attention to. See, this is a diagram based question. Are you able to view this? This is from respiration, where a diagram has been asked. Nitish is blowing air through a tube A. So here we don't ask what happens when you blow exhaled air through a test tube containing lime water. That is a direct question. So we will avoid asking such kind of a question. Rather than we frame a short, a short account on it. Nitish is blowing air through a tube A into a bottle containing freshly prepared lime water. Why does the lime water turn milky? So we also give the children a diagram which helps them to understand the whole thing better. And the options are: exhaled air has less oxygen than inhaled air. Exhaled air is warmer. Exhaled air has more carbon dioxide than inhaled air. The option here, if you note, is not exhaled air has carbon dioxide.
C only correct. Am I right, ma'am?
Yes, C is correct. What I am saying is, do pay attention to my answer here. I am not writing exhaled air has carbon dioxide. I'm writing exhaled air has more carbon dioxide than inhaled air, which is actually the clearer picture, because 100% gaseous exchange never ever happens. And also we know that the lungs are never empty of air. There is always some residual volume. So when we frame our answers, let us try to give options which are very precise. Okay, so we can have this kind of reference to a table and select the correct answers. And then here are assertion reasoning based questions. Here, this is something that we need to give our children a lot of practice. What do you feel, teachers? Have you felt is the same with your students? Assertion reason based questions. How do your children respond to them?
They are troubled only, ma'am.
They are
They felt
troubled.
as
Yes.
troubled.
Yes. Yes, ma'am. Because very often they get confused with the A and B. Both are true, they can understand, but whether R is explaining A or not is where they get totally confused. So the options A and B, we have to give them lot of practice for assertion reason. Because this is some, these will definitely, this format is definitely there in the board. So let us give them a lot of practice. For example, used cooking oil and fat should be thrown in the dustbin and not down the drain. This is a true statement. Cooking oil and fats can harden and block pipes is also a true statement. And this is exactly why we should not be throwing it in the drain. Therefore, the answer to this is A. Both A and R are true, and R is the correct explanation of the assertion. So here we have to ask children to read the statements very clearly. We usually give them reading time. I'm not aware whether you do the same or not. Do you give some reading time for the paper?
Yes, ma'am.
Yes. So because during the reading time, while we are teaching in our classes day to day, we must ask children to use the reading time only for reading. We should not even disturb them by giving them answer scripts at that time, and we should not encourage any other activity during this time. So reading time should be very, very cautiously used by children so that they don't make mistakes. For example, this second assertion reasoning, if you see, drip irrigation is a technique that uses water economically, is correct. Bowery is a traditional irrigation technique which wastes water. This is false. Now, many children, Bowery is a traditional irrigation technique is all that they will read. They will not read beyond that. The wasting what the waste word, if they miss, they will make a mistake because this is false. That is why it is important to read every word.
Excuse ma'am, what is the meaning for Bowery, ma'am? I don't know, ma'am.
Bowery, ma'am, actually these are traditional irrigation. These are like in Tamil Nadu, we have these temple tanks, ma'am, which are used. Yes, which are a source of actually, it was during the Chola period that these temple tanks were dug up.
Yes.
And
yes,
they are actually water harvesting units. Long ago, our kings and our wise men, they knew all about water harvesting. It is only now that we throw all trash into our water bodies and we choke our rivers and canals, and then we say there is flooding and then there is no water. So Bowery is a similar technique which is probably in Rajasthan. So Boweries are used as irrigation technique. So this is again another water harvesting, method. So children should be able to read properly. We should, give them the inputs that they are very, they are required to go through every word. It is a traditional water harvesting technique, Boweries. These are kind of step wells. Have you seen pictures of step wells?
Yes, ma'am. Yes, ma'am.
So Boweries are those which are used in dry areas.
Okay.
So as I said, in Rajasthan, they are very common because, Rajasthan is a very dry area. Then similarly, I will just, because it's already 1 o'clock, I'll just take you to a case study question. This is an example. We gave a small a sample. Now, usually the case study will not be taken from the textbook. We use books of some other publication to get a passage, and then the questions that we frame should not be directly from the passage, because we need to understand that this is a case-based study. It is not a comprehension. A comprehension is something that they will be doing in their English learning, where they are given a passage and questions are asked from the passage. In science or in here, we are giving them a case study where questions are allied to the topic. They are not given directly from the topic. So here, if you see, time is an interesting physical quantity which we use in almost every point in our life. Measuring time was puzzling in early days. Clocks and watches were developed. They make use of periodic motion. A simple pendulum undergoes periodic motion. And nowadays, there are many instruments to measure times. It's a very general paragraph, out of which we have designed questions like clocks that are used in sports can measure. So the correct answer is 1/10 of a second or 1/100th of a second. The scientist who discovered the time period was a given constant for a particular length of the pendulum. That was Galileo. And here, teachers, I would just wind up by showing you this particular question. If the time taken by the bob of a pendulum to move from point R to P, that is from point R to P, is 4 seconds, then the time taken by it to complete one oscillation is what? Now, I will just allow you to read the question on your own. Are you able to see it? Now, this question is not a direct question. Again, it tests application knowledge of the child, because here child has to know what is one oscillation in order to answer this question. So the child will have to know that if it is from the mean position, then it will go here, come back here.
Complete quotation means 6
Yes.
seconds, ma'am. 16 seconds.
So the correct answer is 16. So to arrive at the answer, the child will have to know the complete movement. So this kind of a question does not talk to them. We are not asking them what is time period. We are not asking them what is one oscillation. We are not even giving them state the path from R to P to R to Q to R, and that is one oscillation. We are not even asking that. We have asked them to calculate time period, which they will not be able to do unless they know this concept. So this is one of the examples where we touch upon higher order thinking skills. This one was another passage which we had 4 case study based questions. So I will just take you quickly through it. This was another one where we used a picture to ask them about self-pollination and cases and reflection. 6 centimeter is placed in front of a plane mirror at a distance of 10 centimeters. The height of the image will be. Here, this particular information that the image is, the object is placed at a distance of 10 centimeters actually has no role to play in the answer. This particular addition has been given just to make the question a little more complex. Children have to know that the height of the object and the height of the image is same, and it will never change if with the distance. So that is what has been the trick element in this question. The next one is on lateral inversion. How many letters appear to be different when the word India is reflected by a plane mirror? So here, we know only 2 letters will get laterally reflected, which are N and D, because I and A will remain the same even if they are laterally reflected, inverted. So that is how we proceed with our papers. Even this particular question has some other element. So we give them a lot of picture-based questions. We have asked them to draw a graph, do some conversions, and identify the diverging lens. Why is it never used as a magnifying lens? We have not asked why is a concave lens never used as a magnifying lens. We have rather asked diverging lens, because we have taken care not to use the word concave and convex in any of the questions, because we are going to, we expect the answer from the child. So we will not give them any clues in the subsequent questions also. So these are some of the ways by which, these are give reason. Here they have to fill in the blanks, but it is not given as a direct fill in the blank. We had a table where there were positions A, B, C, D, and they had to fill in according to the alphabets. Some diagram based questions are given. Again, this is an activity based question. We have asked them to draw sketches of 2 stages. And finally, on inhalation and exhalation, where again, this was given. So this was a very quick look at one of our question papers.